Hi, everyone. My name is Don Hatfield. I'm Director of Global Sales here at Intrepid Control Systems. Yeah, I actually had done this presentation several years ago when we were first just starting to support diagnostics over IP, which the technology's basically been around since about 2010. It's already in its third iteration and almost a fourth one coming very soon. But basically, just a quick agenda. I've got a lot of slides. I'm not going to get to all of them, but I am going to provide all those slides to you at the end of the presentation, okay? Or ARPAN will take care of that for me. But first, just why do IP, okay? And how does it work? And I'll talk about the four main steps that are involved in diagnostics over IP. So first, let's just get to why do IP? Well, of course, before do IP, we had do can, diagnostics over can, okay? Many of us are very used to that. The very first simulator I wrote like 16 years ago now for Intrepid was actually a UDS simulator that we actually use a variant of in our training classes to this very day for UDS training. But do IP, very simply stated, is you're taking UDS or other protocols, actually can be done, but primarily UDS diagnostics, and you're packaging the existing UDS frame or message within an Ethernet packet, essentially via TCP. But we'll talk about what parts are UDP and TCP as we go along. Mainly the actual diagnostics are in TCP. And so essentially you're replacing your ISO 15765-2 or long messages for flashing and ISO 11898, which is CAN, with TCP IP and Ethernet, okay? So that's a simple way to state it. To give you an idea of another reason why we've done this is because there is a need on the government side for onboard diagnostics and as well as just diagnostics, because usually there's some special private PIDs that are used for OBD testing as well. But also there's service, and there's actually more people that are missing out of this. Think about all of the people that are doing testing and development, okay? They would love to hook up to a fleet of cars and be able to get key information from them. And DoIP could enable that even over a remote network. So let me keep on moving here and just talk about what DoIP's goals are. You could say that we're trying to remove the gateway. So for some companies, you'll have a gateway that has to protect or be the middleman between the service tool and the rest of the vehicle and connect up to all those networks, okay? And at this point, most vehicles that are made, well, all vehicles that are made today are not zonal, but they're getting more decentralized. So essentially, you would be able to remove the gateway, not have a special box just for doing the connections between everything. Although we have the term of an edge node, which is what really is the middleman for us, but it could be software. And that could be inside of our compute, inside of a zonal architecture, so that you don't have to worry about having a separate box. Or it could be just virtualized, if you will, inside of the BCM or some other ECU. I've seen clusters, other things as well. Even to this day, there are some vehicles that insist on having a gateway to protect the rest of the vehicle. But I would imagine all those are really going to go away as zonal comes on, and then even those functions are actually taken care of by the main compute, okay? Another goal is to configure and flash faster. I can actually have multiple ports and multiple test tools. If you remember in UDS diagnostics, there's actually not, there wasn't really, originally was not an ability to have multiple test tools on the bus at the same time. And, Intrepid being in part a data logger company that does do diagnostics, but must recognize that diagnostics might be done by some other device, like a service tool. We have to watch for it, detect it. There's a lot of legwork we have to do just to avoid colliding with other diagnostics that might be happening on the bus. But with DoIP, I can have multiple concurrent connections all doing diagnostics all at the same time. So I could actually open up multiple connections, flash multiple ECUs, or open up multiple connections, get the information I want, etc. Another thing is to access a vehicle remotely, which I just mentioned, and also to access multiple vehicles, which is, unless you're in production, you're usually not worried about that. But in the production environment, DoIP is actually in part designed to allow you to connect up and perform diagnostics inside the factory on dozens of vehicles or even hundreds of vehicles in the factory. And then at the same time, even with all those extra features, still allow a direct laptop connection. Okay. And I've got a quick stack comparison, but basically I really pretty much stated what has happened. 15765-2 and 11898 are essentially replaced by ISO 13400 or DoIP and Ethernet, but it still has ISO 14229 or UDS for the diagnostics. Now, one thing I did mention, I think it's actually in the text for our advertisement for this, and people I'm sure would be asking, what about zonal architectures or SDV or software-defined vehicles? And the answer is DoIP can easily coexist. In fact, it could be part of it, not a problem at all. Just keep in mind, all you're really doing is you're taking this function and it's going to be another piece of software that's going to be on the compute, basically. Okay, so it definitely fits in and it would work just fine within the zonal idea, the SDV architecture that you've heard of. The first part of DoIP is activation. This will be activating the physical port. Okay, so basically, DoIP uses as its standard 4-wire Ethernet or 100 base TX. Okay, essentially, that is, in fact, let me jump ahead a little bit. I want to get to that part right there. On the OBD connector, or the J1962 connector that you know and love, it turns out that there's some discretionary pins that we've used in the industry for various things. But basically, pins 3 to 11 and 12 and 13, which have been discretionary for a long time, they get taken over by the 4 Ethernet wires that we need. Okay, and then pin 8, in fact, originally was not discretionary. It was marked do not use, that we would never use that a long, long time ago. But essentially, that becomes an extra activation line. So the port, the Ethernet port to the vehicle is not even active, cannot be used unless you assert pin 8 high with VBAT. So basically the voltage of the vehicle, okay? Once you would assert pin 8, then pins 3, 11, 12, 13 become your 4 Ethernet wires, okay? So that's something that in industry, I'll show you a couple tricks that, or at least one trick that they usually use for an Ethernet cable to connect up to between a laptop and the vehicle. But basically, the activation line just assures that you don't have an Ethernet port that's just out there hanging in the breeze that you could hook up to and just do whatever you'd like to. You have to at least assert the activation line. Now, we'll talk more about how insecure or secure that Ethernet port can be later on in the presentation, okay? But I put in some graphics in here that kind of show how the wiring would go, but the key thing here is that there is a specification on the activation time. So for when I bring the voltage up, once it comes above 5 volts, I get 200 milliseconds. Give me a second here. Yeah, right here. Can you guys see the gray flashing circle?
Yes, we can see it.
Okay, awesome, great. So basically you'll see that right here in the graph, from the time it goes to 5 volts, to the time it gets up to its, to the top voltage, it's supposed to go active within 200 milliseconds, okay? And then after you fall down below the 2-volt mark, you got another 200 milliseconds to go to inactivate those 4 Ethernet wires, which is something that, by the way, Intrepid does make test tools, and we have the ability to test this, although this is fairly easy to test with other tools as well. But we've even written some small QA things that we do just to test this kind of thing. But I just wanted to bring that up. And we've already went over the OBD connector itself. So far, what we've talked about is, just how to activate this line and not really how to use it, which is okay. But even at this point, I'd like to have you think about a couple things. First, if you need to use that activation line, you're going to have to test that latency. And I just talked about that, Intrepid's done those tests with our own tools. But could we possibly use something a little different, like 100 base T1 or 1,000 base T1, or gigabit? So T1 meaning 2 wires. Okay. Could you even use Wi-Fi? The answer is actually you could. And even if you look into the spec, the original spec that I used to create the training originally was back in 2012 for DoIP, or not the training, but the slides. Back then there wasn't really a thought about using 100 base T1 or 1,000 base T1. But I can tell you right now, a lot of people see these extra discretionary lines and they'd like to have an extra pair that they can use for something else, right? So the answer is ultimately you could. The other thing I'd like you to think about is, do you really need that active pin to drive the activation line? Well, if you ever happen to do any diagnostics with a German automaker, many of them already have DoIP or something like that built in and have for many years. And all they really do is exactly what this diagnostic cable is. This is just something I pulled up off the internet today. It's shared over and over again, and who knows how many websites. But all they're doing is they're doing nothing more than taking your VBAT on pin 16, connected up with a resistor to get your activation line. That's it. So in other words, I plug in the OBD connector, that activates it. I plug in the Ethernet port on the left into my laptop, and off I go. And I can do DoIP, and I don't need a single service tool, which is another reason for having DoIP. Why have a service tool box when I already have a NIC in my computer that can actually do the job? So before I go on, because we just talked about how do we, where's the port and how do we activate it? Let's talk about the pieces, okay? Inside of DoIP, you have a piece of test equipment. In our case, you might refer to that as the tester, an external tool like our neoVI Fire 2, our Fire 3, our neoVI Red 2, whatever you happen to be using to talk to the vehicle. And in the vehicle, there's the concept of what is called an edge node. And essentially, that is the device, the box, the node inside the vehicle that actually accepts and answers back to all the DoIP requests and responses. It is the middleman between us as a test tool and the rest of the vehicle, okay? And that, again, could be virtualized, part of the software of a single box, The subnetwork is actually all those internal networks that are not directly connected to an external network that we access directly. So for instance, all the Ethernet networks and all the CAN networks and LIN networks would be subnetworks to that edge node. And the edge node would have a connection to them all the ones that should be accessible through DoIP. There's also a logical address, okay? It's really just a 2-byte value that identifies a particular node, if you will, in our network. In essence, it replaces the request and response IDs that we use in CAN. If you think about what we do in, say, OBD, we might have a functional tester present that goes out every couple seconds, and the ID for that is often 7DF. And of course, for each of our ECUs that we talk to, it has their own IDs. But in any case, our logical address is actually a 2-byte value we can use to identify all the particular nodes we want to talk to. Okay. And here's an example of how this could work, how it looks within the vehicle network. This edge node gateway 1, it could be inside of a gateway box that's separate, but again, it really could just be software that's within some other ECU within a compute in SDV. And maybe our neoVI Fire 3 or some other product, whatever test tool that you have, would actually be this external test equipment 1. And so then we're hooked up to this, what it says, IP-based network. That's really those 4 pins that I just showed you. And the activation line is pin 8 that we would activate. Now notice it has network node 2 and network node N. You can have multiple tools connected to the same network, all talking on different ports, different sockets, to multiple ECUs that are behind the gateway, if you will, behind the edge node. Okay. Which means that this could be a data logger here. This could be some other cloud device that's giving me analytics to my team. There's a lot of things that could be connected at once. Of course, everybody wants to connect to the OBD port and get stuff. It could be an insurance dongle. Not that I really care for those, but I don't want to put something in there that's going to, open me up and allow me to be connected to by other things. Not cool. So before I go on, I don't see any Q&A or chat. If there's any questions, feel free to interrupt me. I will keep talking until somebody stops me. But I really wanted to get through until I get to this very first piece here. That is when we start opening up the line, if you will. We've just activated a line. So at this point, we haven't even started talking on it, and we have an edge node in between. So that means there's going to be some more housekeeping, if you will, because we're going to talk to it. We got to know that it received what we're requesting, and that it's formatted right, and that the node on the other side exists. And so I need to find that out. And so you'll see that it's not just send one request, get one response. It's send one request, get an acknowledgement from the edge node, and then the edge node relays the request. The response comes back to the edge node relays the response back to us. So there's multiple steps. We'll go through that all here in a second.
Dan, we have a Q&A from Ashwin. Okay. If you look at it.
So good question. So how can multiple test tools connect at the same time when there is only one ALDL or J1962 or OBD port? Simple. So Ashwin, those 4 pins are Ethernet. And on Ethernet, I can have multiple sockets. So I can have multiple devices on the Ethernet network all talking, just like if I say hooked up a switch and hooked up a whole bunch of stuff in my network. That's how I can have multiple test tools. And you'll see there is a definition in a certain range for specific types of test tools. Okay. So we have the ability to have separate addresses for separate test tools, and the standard takes care of that. I'll show you here in a little bit, okay? And we've already kind of done all the outside the box stuff. We've talked about that. So first thing, how do we get IP addresses? Okay, and really the easy way, because if we're going to be on Ethernet, we have to get an IP address. And so we essentially do things the same way we would do in an IT environment. It turns out that DHCP, which many of us have working in our computers right now and give us our IP addresses to our campus network, or auto IP are both supported. So both of those basically provide the ability to connect up to the network, get an IP address assigned. It is also possible to have static IPs, okay? The spec looks a lot at how to resolve and get your IP addresses for DHCP or auto IP. But I can tell you already, I've run into certain situations where the static IP for each individual car is set and unique. So that way they can still talk to many cars at one time. But keep in mind, DHCP and auto IP take time. And usually time is not on our side when we're manufacturing, and certainly not on our side when we're actually operating a vehicle. We need things in a very timely manner. Okay. Now, when you go through the spec, and unfortunately you have to go by the spec. I'm going to show you some screenshots of some things, but I can tell you specific pages if you'd like. Yeah, and essentially I kind of messed this up a little bit. It should really be the TCP and the TLS at the bottom. Those are actually the diagnostics. It's not in discovery. But the ports that we use for discovering devices out there that we can talk to, if we're a test tool trying to talk to a vehicle, we use, just like the standard number is, port 13400 to discover. Okay. But after that, most everything is dynamically assigned. The only exception to that is that we are forced to use port 3496 if we're going to do TLS, which is a form of security. And I'll talk about that at the very end. So to kind of repeat the four-step process, we have activation, we've got discovery, which is next, then routing activation, and I'll discuss what that really is. It's really just picking the protocol that you're going to use. And then finally, performing diagnostic services. So we've done activation, and I'm going to go through a little bit of how this gets formatted in Ethernet. So basically, in your good old Ethernet frame, it still has its MAC header, its MAC source and destination, still has IPs, and all that, still has TCP or UDP. And then the payload within that, actually, there's going to be a DoIP header, okay, that says, okay, we're going to do DoIP. And within it, you actually have a protocol version, and then this inverted protocol version I'll explain in a second. Then the payload type, which is basically the different functions I'm going to go through, and then the length of that payload. And then finally, the actual payload. That's really where the UDS diagnostics would be in. But we'll talk about the housekeeping we have to do before we even get to that point. That's actually the last step. We're only at the second step. And then inside the DoIP payload, it breaks apart pretty easily. There's a source address, the target address. So basically the source is going to be your test tool. I'll show you those ranges in a second. The target address would be what the OEM decides, and then the actual UBS request is within that. And I actually go through a process of building this all up and showing you how it's built. But the sync section, that's it's really pretty straightforward. You've got this byte 0, the very first byte, and that's called the diagnostic protocol, or that's for the diagnostic protocol. Okay. Or I'm sorry, the version of DoIP. Okay, so basically, the original version, that's if you put hex 1 in there, it's the 2010 version. Hex 2 is 2012, which is, by the way, what our simulator in demo uses at the moment. And all the exchanges you'll see in the slides today, you'll see start with a 02. Okay, the current version of DoIP, which is 2019, would be hex 3. And this is how I can identify what formats I use for different things, because of course, the latest version of DoIP has functions that never existed in the original one. And then the byte 1 is really just take the bits and XOR them all. So if I happen to have 02, you'll see that the next byte is FD. Okay. So, but you'll see that here in a second. The next will be the payload type. Okay. Are you doing discovery, activation, diagnostic transport? There's other things, other functions as well. I'll go through all of those. And then the payload length. And then finally, for byte 8 on, we can put in the payload. Okay. And that holds that UDS diagnostic frame. Okay. Or that payload might be the payload that we're flashing, because we could be doing ISO 15765-2 as part of 14229. And that is, of course, referenced like many of the things we talk about. There's a reference at the end that's like full page of all the other ISO specs and other specs it draws from for DoIP. So essentially, here's that 02 I was talking about for the 2012 version. And then XOR that for the next byte, that's FD. And then your payload type would be those next 2 bytes. And the payload length would be right in there. And here is a whole list of how this is all built. So this is a screenshot right from the specification. And I've really went over this, but it's really there more of a reference for you, okay? Because what you're probably more interested in is how do I determine the payload type? So we can finally get to, doing the discovery and the routing activation, and finally get to doing some actual DoIP stuff. And so the payload types, that's the 2 bytes for the payload type. This is essentially, in the next 2 slides, I've already put in all of the different values, the different types of payloads we can have. So you'll see things about, header acknowledged, negative acknowledge, like it doesn't know what that header is. Things about identifying the vehicle, that's what 1 through 4 basically is. Oh, I'm sorry, actually 1 through 6 essentially is all about your discovery. And then you get to routing activation, that's the 5 and 6. A live check, I'll explain that in a little bit, and the entity status request as I go on. Notice that you've got a whole range in here that's reserved, okay? It's reserved by the document, but usually people see an opening and they may want to use it. So just because we have a standard and it says what is mandatory and this is how you do things, I know for a fact that people will take that standard and the first thing they think about is, how can we do this better? How can we make this fit our particular OEM's situation, okay? And we can talk about those if you have any questions as we go on. And then you can continue on. There's the current version has power mode information request. And then finally, really the diagnostics is actually in the range of 8,000. So 8,001 to 3 is essentially the headers that we're using to actually do the diagnostics. And then if you, for some reason, like it says reserved by this document, again, doesn't stop people from using it, but there is a range that is specifically reserved for manufacturer specific use. In the latest spec, it will actually say VM use for vehicle manufacturer versus using the term OEM, okay? Which I like to use because I'm used to it, but VM is probably the best way, but I really don't like using VM because then I think virtual machine, So now we've physically activated our line. Now we're going to do discovery. How do we discover? Well, basically, discovery is a UDP-based protocol, okay? And there's several different ways we can discover a vehicle on the network, or discover, even if we plug in from our laptop to one vehicle in front of us, we still have to go through the process of discovery. And we can ask just to say, find all vehicles, which is, in fact, I believe that's what we do in our demo. You can ask for a specific VIN, and you can also essentially ask by MAC number. So you can actually put in a MAC and say, I'm looking for this vehicle that has this MAC, and it responds back. That's a good question. Okay, so Gene's asking a question. Besides UDS, what other protocols are or could be used with DoIP, like XCP, for example? So I have to say that they don't talk about XCP in the specification, but they make room for any protocol that you want. So in fact, let me see if I can pull this up. I was going to try to pull up the spec to show you, but I don't know if I'll be able to do it quick enough. But basically, the idea is that you should be able to put any protocol you want within, because all you really have is essentially a payload, just like an Ethernet. You could put anything in there, have any protocols, and there are reserved specific headers within DoIP that you could actually use as an OEM to do whatever you'd like to do. Okay, but at this point, it's really just diagnostics. I'm just trying to see if I can pull up the page, because at least I tell you the page. But anyways, that's really the answer to the question. I hopefully that helps, Gene. All right. So let's keep on going here. So when we're first asking for a vehicle out there, there's really 3 different ways. It says 4 here. We'll talk about that in a second, because the fourth one is actually the vehicle automatically sending us an announcement message, or it's also the way that it responds back if one of the first 3 methods work. So 1 is essentially just a wide open vehicle info request. Is there anything out there? And the vehicle should respond back and give us its information. 2 is for EID. That's really a MAC address. Okay, and then VIN number. You can actually specify a VIN number, send it out, and then that vehicle's VIN could respond back. Seems kind of wasteful if it's just a test tool and you're one vehicle, but the fact is, I might be producing vehicles. I might have 200 vehicles between the ones that are parked out in the parking lot and the ones that are under manufacture right now, that I have to communicate to all of them with a single server, a single set of servers. Okay. And then the announcement message, as I said before, whenever you plug in, if you will, or an edge node goes online, it's supposed to send a vehicle announcement message automatically out on the network 3 times. But also, if one of the 3 modes above work, then the response back comes back with a 4 as well. So that vehicle announcement message is also the ID response and provides all the information in both cases about the vehicle so that you can connect up to it. Oh, Jay, you're hunting me down. It's good to see you. I was just thinking about you yesterday. Does DoIP only support protocols or request response in nature? That's a good question, because the way that it's designed, I would say that it's really its use is really to be as request response. But I mean, we can flash over DoIP. So doing things like streaming, I think, are possible. Pub and sub is probably more along the lines of what DoIP can do. But if we would want to stream, I would have to say that DoIP is going to be very inefficient, because you're putting a middleman in the middle that's deciding who's got to get what. And so that just causes a delay. So at least that's my answer. I don't know if it's the right one, but that they don't mention anything about streaming, only that you could use other protocols instead of the ones that I'm talking about. And there are reserved IDs that vehicle makers can use to put in new protocols, things that they've dreamed up. So hopefully that helps, Jay. All right, we've already talked about this, and I also talked about mode 2 and 3 by MAC and VIN. And I actually have the structure in here because I find it just not really a rant, but when I read a spec, and that spec might be 50 pages, 100 pages, I find myself bouncing back and forth. And I like to construct the messages in the bytes for you so that you see where everything comes from. And therefore, you understand if you have a problem, you can look at the actual messages and troubleshoot them. Because that's kind of my background. I started as a technician, back in 1992. So I'm very much a technician-oriented troubleshooting. And so I do a lot of the things like divide and conquer and isolate the problem. So anyways, hopefully this helps you out. I've got this all laid out in the slides. And so when the response comes back, again, the 02 FD is just, in this case, I'm using the second version of the spec, and the FD is the opposite of that, just flip all the bits or XOR them. And the 0004 is the response back of the VIN, the MAC, and group ID. So, but the group ID is usually, unless you're at a point in, say, production when there's not a VIN programmed, then it will assign like the 6-byte group ID. But that's uncommon. It only happens in certain parts of manufacturing versus, or maybe, good. So I have another question here. Is DoIP only used for diagnostics and flashing, or are there other uses of DoIP? So that's a good question. For me, ultimately, it is really designed to help out with diagnostics and flashing, help out with the manufacturing, but also it's kind of laying the groundwork for the things that we need in the automotive industry today when we're doing pre-production vehicles. Namely, I'm usually going to have a data logger in the vehicle. I might have a separate analytics device in the vehicle. I might have, for instance, here at Intrepid, we make the value log, and the value log is a device that connects up and downloads data off the vehicle and then displays it in an analytics type of format and, really like kind of IoT application versus, say, our heavy duty loggers, like what we used to make the Ion, now it's the Fire 3 and Red 2, that do data logging and could do DoIP both at the same time. And I wouldn't have to worry about unplugging them if I'm bringing it in for service. The service guy can still hook up and he can still connect it over DoIP because he has his own sets of ports. So diagnostics and flashing is mainly what it's designed for, but the other uses really end up being part of the use cases, if that makes more sense. And you'll see that as I go through, there's a couple of key tables I've taken out of the spec and put into these slides, and I'll point those out as we go, okay? Hopefully that answered your question. So now we've talked about the routing, how we can just, how we can activate that physical line. Then we talk about how do we discover the vehicle, and let's just say we've discovered the vehicle. Now it's time for routing activation, okay? So for routing activation, we need to tell it how we want to talk. And that kind of gets to the last couple questions because the activation type tells us what type of communication we're going to do, okay? So essentially, we're going to tell the edge node we'd like to do communications in a certain way, and we'll get a response back. And at that point, once we get the proper response back, then we can start to do diagnostics. So for instance, after we've done our discovery, we've got a connection. At this point, we're opening up a TCP connection, essentially. And then we're going to start to do, or I'm sorry, it's going to be, actually, yes, I believe the routing, I might be wrong here, but I'm pretty sure routing activation request actually happens over a TCP socket, okay? So we would send a hex 5. That's going to be the routing activation request. We get the response back on the on 6. And let me jump ahead to the table. This little table here actually has the keys to some of these questions. Yeah, give me a second. I'll get to the other one. Yeah. So, but anyways, the one that says value 16, it says default. What that really means is that's really the UDS diagnostics. Okay, that's the default way of using it. Okay. And then the 116 is actually for diagnostics by regulation. So that would be like, your J1979, things like that, Euro OBD. Okay. Worldwide harmonized OBD would be under that. Okay, as well. Okay. Now there's the whole range that's reserved. I'll skip central security for a second, but you could do whatever you want with all the additional VM specific use stuff. You've got an entire range and you can set up whatever diagnostics you want and just give it a different value to tell the edge node what you'd like to talk in. Now, of course, the edge node knows what it can do so that it will respond back positively or negatively based on the value you provide in that mode 5, if you will. Okay. Let's see. Let me read Paul's thing here. Learning expenses. Has a separate connection on the same network for streaming. Yeah, that's a good. Okay, so that's a good point. I know Jay was talking about streaming. I was talking about having streaming within DoIP. Okay, so but you could at the same time, if it's possible through the edge node on that particular network, you could be doing anything else, okay? But the normal use of it is that it's reserved only for DoIP, that particular port. But I can see a time where you just don't even bother with, say, DoIP necessarily, and you start doing things like SOAD, which is socket adapter, talking directly to ECUs. But But anyways, it's still a good point. So the activation type is actually what establishes what protocol you're supposed to do, so to speak. That's what, what the value is there. But I'll tell you right now, it's, as far as I know, and it looks like, Paul, your experience is the same. I never really see anything more than UDS and flashing. Okay, so basically ISO 15765-2 type of flashing, which sounds kind of crazy because it's like taking CAN long messages, wrapping them up in the Ethernet frame that's actually better at transmitting large payloads, but it can be done in it, and I've seen people do it. And Jay is asking another question, so hopefully that answered Paul's question. He had a good comment. Jay, so you asked about central security. So central security, I personally have not run into anybody using this, okay? But the current version of the spec has the ability to do TLS, to have a, a lot of OEMs, apart from DoIP, yeah, and Jay, you are correct that basically central security could be any homebrew type of security that they want to implement on their own, separate from DoIP. So you're right that this could be a way to like unlock the ECU. They could really do, make it a unique protocol underneath that, because everything below that is, beyond that central security activation, is basically up to the OEM to do whatever they'd like to do. Okay. So hopefully that answers Jay's two questions. Let's see, Bill's got another question. Is specified somewhere that DoIP that's it. Yes. Okay. So Bill, a good question. So is it specified somewhere that DoIP diagnostics is over TCP, or is it open to utilize UDS? So after activation, all those diagnostics, those are all under two different protocols. Either it's TCP or TLS, which is really going to be TCP underneath it, because that's TLS is a security protocol. But it is correct that, as far as I know, and I did read through the spec again this morning, that the latest one, that TCP is the only method by which we're connecting in Ethernet using the IP suite. Okay. All right. I'm trying to move fast, but I know it's 12:43 and I want to leave some time for questions. We got plenty of questions here. So I'm going to kind of blaze through this next part to get to the diagnostics, because there's a couple tables I really want to show you. Okay. But basically, we already talked about the activation request. I have all of the tables that are important for being able to tell what the responses are and how to interpret those responses. Okay. But we've already kind of talked about that. There's actually a lot of different things on the response back, because these are all potential error codes too, like denied because I don't know what the source address is. This would be similar, vaguely similar to the error codes you might get if you're trying to do a direct memory access through UDS. You get some error codes and diagnostics. Sometimes they mean something very specific. Sometimes they're very generic, like value out of range. I can't remember exactly what it's pronounced as, but it's like that's the default. But anything goes wrong, request out of range. It's like, what does that mean? Out of what range? So, but anyways, let's keep on moving here and talk about three things that are new in the 2019 spec. The first thing is really staying alive, the alive check, which is essentially you can use it kind of like a watchdog to make sure that the ECU you are talking to is still alive and is still kicking. Okay, not necessarily that the connection's being used, but that the ECU itself it's still reachable. Okay, and so you have the ability to send a live check request and get a response back. So that's something that's new. I've not seen that myself yet. But DoIP entity status is actually something sorely missing from the 2012 spec, because in the 2012 spec, there was no real way to tell, like, how many connections could I have? you'd have to guess, or you'd have to know as an OEM. And that's kind of important if I'm trying to do multiple things, right? So you can actually request that under the 2019 version, and it will actually give you a whole list of information, which the list is actually quite large, but this page 25 and 26 in the ISO 13400 spec, that's 2019, that will tell you all of the different responses, the things you can get back when you make that request, okay? And then power mode info, which this one is a bit confusing to me because of the way they talk about it, because on one side they say power mode, like, is the ECU powered up, is kind of what you'd think, but it's really roughly similar to extended diagnostic mode. So for instance, in UDS, you have extended diagnostic mode, programming mode, etc. This really just tells you whether or not this particular node is ready to talk to, or of course, it does have non-supported in there. That's just if the power mode request is even supported, okay? Then finally, we're to diagnostics. So we got through that 4-step, overview. We're finally getting ready to send some diagnostics, okay? So the diagnostics all happened in the range of 8,000s. So your requests would go out in 8001. Of course, it would contain your source address as the test tool, and then the target address, the ECU. And here is that list of logical addresses, which gets back to what could you use DoIP for? And this is what they're expecting so far, okay? So you've got some vehicle maker specific ones that are reserved. You can use those whichever way you'd like as an OEM. You've got your legislated diagnostics. So this would be stuff for J1979, Euro 5.6, any of the emission stuff would be in this range, okay? Some of these things that say external vehicle manufacturer, aftermarket, diagnostics test equipment, that would be things like Intrepid would make, or other companies would make to do diagnostics in the factory or in the field on the vehicle, okay? Data loggers would fit under the next one. Any of that kind of stuff that says internal data collection or OBD equipment on board, that's really for the vehicle manufacturers. But there's also other ones like this one right here that's really made more for Intrepid or other people that make data loggers to capture data. Also insurance companies, fleet data people. And there's also a whole separate range that's reserved for heavy duty vehicles. So all the people that use J1939 actually have a whole separate range reserved for them for using this as well. Okay. But I'll give you that at the end of the day. But I do want to blaze through here because we've only got about 11 minutes left. So I've already went through the ranges, and essentially all you're really doing once you pack this together is the header is going to be 8001, and then you're going to have a source and destination address, and then you just pack in the raw ISO 14229 frame, just like you would have done in CAN within the DoIP payload. And that's how you send a diagnostic request. Okay. And this is just a request example that breaks all the pieces down. Now, the thing that you have to remember with DoIP is that you're not talking directly to the ECU. So that means it's not that I just send one request and get one response back. I'm going to send one request that gets to the edge node. The edge node actually responds back either in a positive or negative way to me to tell me I got what you sent and I'm okay with it. I'm sending it to the ECU, which is a positive acknowledgement. Or if for some reason it does not like it, it's gonna send us an 8003 back to the test tool, if you will, and it's gonna say a negative acknowledgement and why it did not work. Okay, and I believe I got the list of that in here as well. Once you get that positive acknowledgement back, it gets forwarded from the edge node to the ECU. So the ECU simply receives its requests, whether it's Ethernet, CAN, LIN, FlexRay, doesn't matter. The response will come back on that same network back to the edge node. The edge node will then repackage that response, send it back to us in the payload, of another 8001 diagnostic message. So the requests and responses always come back with a header 8001, but of course, the source will now be the ECU or the device in the car you were talking to, and the response back is going to go to the test tool. So the source and destination are flipped around. Now, security. Up until now, with the exception of that one extra mode for activation, there's been no talk of security at all. And to this very day, there's only one form. Well, actually, the 2012 spec did not have security in it at all, except for that particular mode for central security. But in the current one, there is actually the ability to do TLS. So after you do your activation, you can then initiate a TLS socket and then do everything you want through that TLS socket. Okay. Discovery is still unsecured. Okay. And there's section 625 inside of the spec will tell you more information. And let me give you just a quick overview of like what Intrepid does to support DoIP and diagnostics. Yeah, all of our products support DoIP and diagnostics. I would say, yeah, anything that has more than one vehicle network on it. So that's our neoVI Red 2, our neoVI Fire 3, our old neoVI Fire 2, we still make that. Vehicle Spy, of course, our software that runs all of that also supports it. And we support it as a data logger, standalone, or with a PC, okay? And so if you're inside of Diagnostics to Vehicle Spy, you just simply pick the transport layer. So in here it says CAN, DoIP, and SOAD socket adapter. So if I'm talking direct Ethernet to an ECU with that nothing in between, I would use SOAD. But all of those are really just different formats. I can do the diagnostics across any of those, okay? And I've got a couple screenshots in here that show how we can deal with diagnostics. And we have a whole diagnostics training class. It's not focused on DoIP at all, but it's focused on the UDS stuff, okay? And that basically just kind of tells you, in fact, by the way, my helpful hint for cheating is whenever I want to know how to structure a message, I go into Vehicle Spy, I put everything in here for diagnostics, and it builds it right down here at the very bottom. So in this case, you see 70, which is my request address, 3 bytes to follow, a mode 22, which is to read a DID, and then BEEF is the DID I'm reading. Okay. And I can do the same thing with DoIP, in this case, using the second version of DoIP. So 02FD, and then 8001 is the request. And then as you go on, you'll see that it's all actually already packed in there for you to do the diagnostics. You get down here and you finally see, oh, there it is. I have a 070E8020 that, yeah, I'd have to break that down, but you'll see mode 22, BEEF. It's all right there, broken down for you. And we do the same thing for socket adapter too. So I finished without going over time. I think we scheduled until 1 p.m. I'd like to open up the floor to questions and answers now. I know we had a number of them during the presentation, but I'm happy to address any questions that you have. Yeah, it looks like no questions. Jay, I thought you'd ask more questions. Obviously, Jay and I know each other for a long time. Jay used to work at Intrepid, so it's always good to see him. Good guy. Arpin, I guess I'll let you take it over and give a last chance for questions. Otherwise, we can close out the presentation.
Yeah. Thank you, everyone. Thank you, Don, for doing the presentation. We are going to post this recording on our YouTube channel, and we will also share slides right after this. So if you sign up through our Zoom webinar, we'll email you the slides. And if you go to our YouTube, subscribe to our YouTube channel, and we'll also attach link to our PDF for the slide on our comment section of our YouTube video. And yeah, we're planning to do this more. If you have any ideas on what webinars you like to see from Intrepid, feel free to leave a comment and let us know. Jay said would love to have one for some IP. We'll definitely make one.
Yeah, that's good question. Arpin, don't we have, well, we're working on the some IP training.
Yep.
Right now, Jay. So a hands-on training with simulated endpoints and everything. And eventually we will have a presentation. I thought Colt had done something like that.
Yep, we did. We did a 5-minute intro of some IP video on our YouTube channel. He's making a full 1 hour long YouTube video for some IP. So if you haven't subscribed to our YouTube channel, please feel free to do that. I just released a poll, which I should have done earlier. So if you are interested in getting a vSpy demo with DoIP, please feel free to say yes on our poll, and somebody from our team will reach out to you for a free trial of vSpy 3 with DoIP feature or DoIP features. So please fill out this form. I'm gonna pause the recording, and yeah, if you have any questions, feel free to let me know.
Yep. Yeah, you can also contact me, by the way, through my LinkedIn. It's probably a lot easier if you can of course text me or email me as well. I've got that all on the screen here. And if you have any other questions, yeah, you can reach out to Arpin. I should have put Arpin your information on here too. So
yep.
Jay, you're flattering me.
And
okay.
ask AVB. AVB is a really good topic. I think we should schedule a webinar on AVB. We are doing a data logging webinar next month. And we are also doing a gateway webinar as well. So that's coming up, but more automotive Ethernet looks like. We need to do more automotive Ethernet webinars.
All right. Well, thank you very much, everybody.
Thank you all.
Have a good day.
Thank you.